on this side? Because I think the average person is less than. It doesn't have a measurement, so I'm not sure. All right. So we are going to talk about these types of curves. So you saw a lot of pictures of them. So first question is, what is a density curve? So is somebody willing to understand or share with us their understanding or the definition that they have obtained about this? Max. Okay, so he said a graph that shows probability with the space underneath the curve being equal to all probabilities. So I think you're getting to our normal distribution, so we're going to come back to you. Jenna. Density curve. So again, I think you're talking about normal too. So the pictures you guys all saw said this is normal, this is not, okay? A density curve just means any curve, okay, where it contains the maximum probability. So when you guys learned probabilities, what is the maximum probability? 100% or 1 as a decimal value. So what they are saying is they are saying that there exists a curve where underneath here is every possibility. There's 100% chance of something, your data being underneath that piece of curve, included in this shape of the curve, okay? Which also means if I split it certain places, I could figure out which percent of my data would fall here or over this or under this and all of this kind of stuff, okay? So that's what we're going to be walking on. But the curve could be like this, and then it's a little harder to tell what percent of the data, I don't know, okay? But any of those curves, and so that means, again, when we are finding the probability of something happening, it's going to be a decimal, or it can be represented as a percentage, okay? But it will always be under 100% or a decimal underneath 1. Unless we're talking about the whole thing, then it would be equal to 1. Somewhat like when you get percentile rankings on things like SATs and stuff like that, when you get your score results back, right? They're giving you an indication when they say you scored in the 90th percentile, that you scored at or above 90% of the other students taking the test. Nobody's going to score in the 105th percentile. It doesn't make sense because they can't score better than 105% of the people because the entire population is only 100%. Okay, so this is any curve in which all your data essentially is underneath that curve, and that represents the probabilities of those things happening, which is the same as percentiles, okay, or percentage of it happening. All right, what did you guys see for normal distribution curves? So Cassidy, repeat what you said nice and loud for everybody to hear. Okay, so she said when a mean, median, and mode of a density curve is all the same number. I like that you threw that new vocabulary in there. And Jenna, say what you said again. Good. Good, and we call that skewed. So this curve that I drew right here is skewed, okay, in one direction. So when the curve is symmetrical, okay, meaning it has that change in rate on both sides that is the same, we would call it a normal curve. And Cassidy has pointed out a really important piece of information about our normal curve. In order for that to happen, did you see how those curves were drawn around like bar graphs, right? And that represents the amount of data, like our dot plot, that would end up at that one. The biggest one had to be in the middle, right? So the mode had to also line up with basically where the average was, which would also have to line up with basically where the middle piece of data is. So do you guys understand why the mean, median, and mode would basically, yeah, they don't have to be exactly. When it's perfectly normal, it's exactly, but we would give a little leeway for something that fits the definition. You would see those things line up together in the middle. That's the only way to get that curve that way. Carolina? It's both. So if you collected the data and put it all in there and then you asked me, what is the probability of me asking this person and getting this number answer, or what's the probability that they take this long on the maze, we would go to our data and think of it as a curve containing all of the data underneath it, and we would say that's 100% probability they took one of these times that's underneath the curve. Given the time that you've given, the probability they took that time or more would be this section right here, and it would be a certain percentage of the whole thing. Okay, so it is both. It is a picture of your data that produces a curve, and then you can use it to calculate basically a portion of area underneath that curve. So you can think of your data as filling the area underneath the curve, and there's 100% of the area underneath the curve. And then when you're talking about certain portions of data at or above or below certain numbers, you're picking out only a portion of the area underneath the curve. So you're getting something less than 1 or less than 100%. Okay? All right, so are we okay with when people are talking about curves, what they're talking about and what normal looks like versus not normal? Okay? And did you guys see our Canvas page? Just like a shout out for a second. People watching the video are not going to like this. See? Normal, paranormal distribution. Laugh, people, laugh. Come on, I tried so hard.
Do you have a shirt?
I don't have a shirt like that.
You should sell shirts.
I don't make the math puns. I just go find them. Okay?
But you can make money off of other people's genius. Yeah, just selling
Of other people's genius.
That's
All right.
capitalism in a nutshell. Share money off of other people's ideas.
I'm good at it, huh? All right. Review. Mean. What does it mean?
Someone who isn't nice.
Average. Someone who isn't nice. Sometimes that is what it means. So in this context, we're looking at average. Okay? So remind yourself and write down the word average. Is that a measure of center of the data or a measure of spread?
Spread.
So the average tells you how spread out the data is? So when I say the average on our test was 70%, do you have any idea how spread out? Every single person could have gotten 70%, right? And the average was 70%. Or half of the people could have got 100 and half the people could have got 40. And then the average would be 70% also, right? So let me ask again. Is the average a measure of center or a measure of spread? Center. Okay? Center. You have no idea how spread out the data is with the average. You only know that's one way to calculate the center. Why do you guys ask me about the test average when you get your result back? Okay? Isabel. Right, because you're trying to see if your score is around that, right? Or give Miss Dahl a hard time if the average is really low, right? That measure of center. I don't like the average as much. I'll be perfectly honest with you guys. You know why I don't like the average? If one person scores a 25% on my test, it brings down what I think are the actual results, because I would consider that one person an outlier. You guys saw our tally marks from our last test, right? Okay. Most people are achieving really well, but if those D's and F's that were down at the bottom, if those F's are pretty low, they're going to bring the average down a lot further than what it might be, even though it's just an F. F is from 0 to 50. So the number value will change the average, right? Jenna? When they average something, right, because they don't want scores to change it drastically. Now, in our class, I don't feel, this is my interpretation, that the high scores change it as much, because you saw how many high scores there were, right? Okay? So maybe I could throw out the couple of people that got over 100% because they got the bonus question right. Okay? Frankie. Okay? But, Max. But other than that, you saw how many A's there were, right? So is 100 really an outlier when there's a bunch of people at 96 and 94 and 92? 100's not that bad. But when there was only 4 F's in total and one of them was a 44% or something, that is an outlier in our scores. Do you get what I'm saying? So I don't like the average as much as I like maybe the median. I want to know where is 50% of my data falling. And you guys would have a totally different picture of our test that way, because you saw the numbers in our tally chart last time. If we picked out the median, it would be 80-something, okay, because half of the people had B's or better, okay, and then the other half would be below that.
On the Canvas, I know if you hit the little bookmark,
Uh-huh.
it'll tell you the average
Uh-huh.
and the high. Wait.
It'll tell you the average, the low, and the high.
I think it also has a little
It
box
does.
and whisker
It does have a box and whisker plot. I click on it and see if it tells you what if it's using the 5 special numbers. Because I don't know if it's just using average and giving you an idea of the spread, or if it actually calculates it. But you're right, it totally has that picture. Mm-hmm. All right, so sometimes I like median, sometimes I like mean. Like Cassidy mentioned, mode is also a measure of center. Okay, next up, standard deviation. Okay. So standard deviation, write this down, is a measure of spread. What's that? No, median is a measure of center. Okay? Anything that's telling you about the middle of your data, which is what averages do, what the middle piece of data does, what the mode does, because it's telling you where the most things happen, are measures of center. Okay? Measures of spread are describing how spread out your data is. So this word standard deviation, we're going to learn more about it, but it's how much something is deviating from the average or the middle of your data. Okay? And we standardize it, so that's how we are able to figure it out. So I'm going to get 8 pieces of data from you guys, and then we are going to figure out how standard deviation is calculated. We're going to split up the work. All right, so if you're willing to share with me how many hours of sleep you got last night, let's see if today's is any different. Raise your hand. Kingsley. 8. Way to go, Kingsley. Frankie. Oh, 8. Way to go, Frankie. Cassidy. 2. Wow. Carolina.
Thanks, guys.
4. Not good either, Carolina. Max. 8.5. Max. Okay. Randall. 7. Okay, Sydney. 6. Ian. 8. Okay. Here's our data. Very not random. Totally biased. Missed all picked people. She didn't even use her calculator. What was she thinking? Okay. So I'm going to go ahead and calculate the average real quick. And bias, because then I picked from the volunteers and I didn't pick everybody. So I'm sure there's some bias in there somewhere. Right? This is not a good study at all. Okay, so the mean is 6.4375. Okay, so the mean's not going to change, but I'm putting it here to help your arithmetic easier in the chart. So the mean is the same for our entire set of data. So write this down. 6.4375, yeah, if you can't read my writing, sorry. Okay, now we're going to split up the work, so I don't have to do everybody to do this. So this side of the room, groups 1, 2, and 3, you guys are going to finish this chart for the first 3 pieces of data. Okay, so you need to subtract. You need to find out how different the mean is from the current piece of data, and then you need to square that number. So this column should be positive because you're squaring it. So whether it was negative or positive to begin with doesn't really matter, because then you're going to square it. Middle 3 groups, 4, 5, and 6, you guys need to do the next 3 pieces of data. Okay, last 3 groups, 7, 8, 9, only have 2 pieces of data. Okay, so I want you to go ahead and do that, and then come fill in the chart so people can have complete note guides. Use this pen so that it gets recorded. Check with some. Okay, so our sum of our square of our differences is 40.16. And did you do this part? Yeah. Okay, so what did we get there? 2.395. So then we get a standard deviation of 2.395. So what this means is when we distribute these things and we find the mean or the average, we could find some measure of center. And then we would kind of judge how far somebody was away from the center by using standard deviations. Like, oh, you're 1 standard deviation away from the center. All right. You're 4 standard deviations away from the center. Like, do you sleep? Or, wow, do you sleep all day? Okay, depending on which side of the center they are on. So what we use is we use standard deviation to kind of take all of our numbers and measure how far they were from the center individually. And then using this formula kind of generalize like, okay, here's an average distance that the data tends to be from the center. So then when I talk to people now, I tell them how many standard deviations away from the center I am. That tells them whether I'm close to it or far away. Okay? So go back. Was standard deviation a measure of center or a measure of spread? Spread, okay, and you can tell algebraically by the formula, and you can also tell by what we were doing, right? We just said I would tell someone I'm this many standard deviations away from the center, so I'm telling you how spread out the data is, right? From the center, measuring from there. Also in the formula, look at what you did. You took each piece of data, you subtracted from it the average. Right there is how far apart something is, right? How far is this piece of data from what I called the average? Why there's the squaring and dividing by n minus 1 instead of n if you're averaging stuff has to do with mathematicians putting in a little bit of cushion to allow them to have extra error, because if you're going to present your data as something for someone to use, if you didn't allow yourself a little bit of extra space, right, for error, then your results might not produce what people were looking for. So that's what those kind of things do. So if you look at the next, at the formula down at the bottom, this is the formula put all together. So it looks pretty hideous.
Is that the same thing that we did?
This is what you guys just did. Okay? So the first thing you guys did is you took each piece of data and you subtracted it from the average. So this X bar means average. Okay? And X with a little, kind of like our sequences, is each piece of the data. Okay? Then you took the difference and you squared it. And then what did you do with all of those? Jack? You summed all of them up. So this guy right here is sigma. It's a Greek letter, okay? Maybe you've seen it in movies with fraternities or sororities or something, okay? This is sigma. In mathematics, we use sigma to mean summation, as in add them up. You know a mathematician's not going to write, now add up all these things in the middle of a formula. There's going to be a symbol or something that represents what they're supposed to do. So sigma means add everything up. This is called summation notation, okay? It means to sum. So in math, sigma stands for summation. So you added them all up, then you divided them by one less than the number of data, and then you square rooted it. So now, do you want the good news?
Yeah.
You don't have to ever do that again. I'm going to give you 50 pieces of data on the test, and you have to do that. Just kidding. Okay, so you guys don't have to do that. Your calculator can do it for you. So you're going to go. Frank, I'm going to borrow your paper just for a minute. No. Yep. Yeah, your tests and quizzes will be all calculator-based in this unit. Okay, so some things that are different and some things that are not. First of all, what doesn't change on the calculator is if you're trying to do something with data, you need to go to stat and you need to edit and you need to enter your data, okay? I'm going to go to one list. I'm going to clear it and I'm going to enter our data on number of hours of sleep. I don't care what's in list 2. Now, in the past, when we were doing data, we were doing two-variable or bivariate data. We were saying, oh, here's the year, here's the number of infections. We were making scatter plots. We wouldn't do that with this data. What kind of plots have we made so far with our one-variable data, where we're just looking at a list of a single number? Dot plots, box plots, okay? Your calculator can do box plots for you as well, okay? Box plots actually aren't bad to make by hand. What was the worst part of making your box plot? Trying to get everyone's data off the board and put it in order, right? Sucked. Yeah, I had to do it too. I did it too, yeah. Right? Couldn't read how people wrote. Yeah, same thing. Okay, so this will do this for you. If this was our sleep data, I now go to stat, and just like before, I go over to calculate. So in the past, we ran a bunch of regressions because we were trying to see how these two variable things were related to each other. That's not what we're doing now. We just wanted to calculate all the basic things that you do with one variable. What's the average? What's the quartiles, the median, all this stuff. So we're going to choose number one variable statistics. We're going to press enter. Those of you that have newer software, it will ask you which list. Just make sure it says list 1. I could type list 1. It defaults to list 1. If I was using a different list, I would type that after this, okay? I'm going to press enter, and look what happens. X bar. What did X bar mean? We just talked about this. Average. So the average was 6.4375. Hey, that's what we got. Okay? Sum of the averages squared, because there's your sigma notation. The S stands for standard deviation. Okay? Pretty close to what we calculated. They didn't do any rounding. The N equals 8 means there was 8 pieces of data. The minimum was 2. The first quartile is 5. The median or second quartile is 7.5. The third quartile is 8. And the maximum is 8.5. automatically will take all the numbers from that list, whether there's 8 numbers or 800 numbers. We'll order them for you and spit all this stuff out so you can automatically already know 2 measures of center, your median as well as your mean, okay? And also, you can see the spread because you have your 5-number summary. You can see your min, your max, and your quartile. So you could draw that box and whisker plot to see your spread. And also you have that standard deviation measurement, which is going to help us understand spread a little bit better too. Julie? You actually can. If you go to stat plot and go into the plot, if you, instead of choosing the scatter plot that we have always chosen, you can choose a box and whisker plot with outliers marked or just a box and whisker plot where you're not considering outliers. Choose your list and then, oops, I got to turn it on. And then if you go to zoom and you choose choice 9, which is stat. Oh, sorry, I have something else in my thing. Hold on a minute. Let me clear that out. There's your box and whisker plot. And if you push trace, it will trace over your Q2, Q3 maximum to your pieces of data. Okay? Yeah, there's a lot of things online too. If you don't have a graphing calculator at home, there's a lot of places online where you could just type in all the data and they'll give you the 5-number summary as well. Okay? So you can do your homework without having to have the calculator, but just make sure that you know how to do it. So what we're going to do tomorrow, we're going to take our homework quiz. We are going to then